Okay, let's look at this question from November 2015. It's the fertilizer question from November 2015. It says, to ammonia is an important fertilizer. Large amounts are prepared from hydrogen and nitrogen in industry. For the industrial preparation of ammonia, write down the name of the process used. Please make sure you spell it correctly. It is the Haber process. Write down a balanced equation for the reaction that occurs. Now, all the information is in the question. It says to you, they are prepared from hydrogen and nitrogen, and we make ammonia. So we're going to write here hydrogen, and we know it's a diatomic molecule, plus nitrogen, which we also know is a diatomic molecule, gives me ammonia. I've got 2 marks already without balancing it. So if you suffer to balance, just write my reactants and my products, and you've got 2 of the 3 marks. When we make this, we use 3 hydrogens for 1 nitrogen to give us 2 ammonias. Where do we get the nitrogen from? It says, what is the source of the nitrogen? It's from the air. Remember, the air is close to 70% nitrogen, so we do fractional distillation of the air, okay, because the nitrogen's got a different boiling point to the oxygen. So fractional distillation of air gives you the nitrogen. It says the yield of ammonia changes with temperature and pressure during its industrial preparation. The graphs below show how the percentage of ammonia in the reaction mixture that leaves the reaction vessel varies under different conditions. So if we check this graph here, at 300 degrees, can you see my yield over here is close to 80% at 400 atmospheres, because here's the pressure in atmospheres. So, and at 100 atmospheres, I've already got 40% yield. And then if we check here on the next graph at 400 degrees, which is hotter, so you actually start off with a lower yield and you remain at a lower yield for all of the pressures. And over here, if we go to 500 degrees, you can see the yield is even lower. I mean, my yield at 400 atmospheres pressure is only 20%, which is actually less than what it is at 100 atmospheres with 300 degrees. So this tells you, remember that this is a equilibrium reaction, and so this tells you that at a higher temperature, the equilibrium is being driven to the left because this reaction is exothermic. Okay, it says use the appropriate graph to estimate the percentage of the ammonia in the reaction mixture at 240 atmospheres. Well, this line here is 240 atmospheres, and it says 400 degrees. So for 400 degrees, we must read it off this graph here. So where do these two intersect? They intersect there at 40%. So at 10.2.1, the percentage of ammonia is 40%. Then it says to you, state 2 advantages of using high pressure in the preparation of ammonia. Well, as you can see from this trend in the graph, with increasing pressure, you get increasing yield. So what is the advantage of using high pressure? It increases the yield. Okay. And what is the other, in any equilibrium reaction, what happens if you increase the pressure? If we have a look here, this system, if we increase the pressure, it favors the forward reaction because the forward reaction only makes 2 moles of gas. And also increasing the pressure is like increasing the concentration. So if you increase the concentration of the reactants, which is what happens with the pressure, increasing concentration of reactants then speeds up the reaction. So you can say speeds up the reaction or increases reaction rate. Then it says to you in 10.2.3, the advantage of using a low temperature is the large percentage of ammonia formed. And you can see that because at this 300 degrees, our yield is always much higher. So it says to you, the advantage of using a low temperature is a large percentage of the ammonia. What is the disadvantage of using a low temperature? This will be a slow reaction rate or decreased rate of reaction. Okay, low rate of reaction. Now it says to you, ammonia is also used in the preparation of other fertilizers such as ammonium nitrate. Calculate the mass of nitrogen in a 50 kilogram bag of pure ammonium nitrate fertilizer. Now usually in these questions they've got a percentage purity on the bag, but now they are telling you it is 100% pure. All you've got in that bag is ammonium nitrate. So it asks you the mass of nitrogen. See here in the question it says the mass of nitrogen. So we have to find the percentage of nitrogen in ammonium nitrate. So to do that we have to know that the formula of ammonium nitrate is NH4NO3. So have a look here, 1 nitrogen, 2 nitrogens. So I've got 2 nitrogens per molecule of ammonium nitrate. So that's going to be from your periodic table 14 plus 14 over 14 plus 4 for the hydrogens plus another 14 for the nitrogen plus 16 times 3 for the oxygens times 100. That's going to give me my percentage nitrogen. Okay, that is going to be, this is 28 over 80 times 100. This is 35%. Okay, so my whole 50 kilos is ammonium nitrate, but 35% of that is nitrogen atoms. So 35%, okay, this is the mass of nitrogen, is 35% of the whole mass of the bag. This comes to 17.5 kilograms if you put it in your calculator. So this question's unusual in that the bag is pure fertilizer.